We are going to discuss experiments, quasi experiments in social sciences. This is chapter 13 from Stock and Watson. We'll have a couple of videos on this. What and why experiments, quasi and natural experiments, threats to validity, internal and external validity. Another video will be on difference in differences estimations, regression discontinuity designs. In one of the video, we'll discuss analysis of star data using STATA and R, regression discontinuity designs using R. So you can watch these videos to understand how we use this difference in differences estimators and regression discontinuity designs, and what are experiments. Why experiments? There are three main reasons. They provide ideal benchmark for assessing causal effect in observational studies. These experiments are very costly, but many a times very influential, so it needs to understand their correct impact and basically understand many a times one group gets a treatment, that is a treatment as if random. So that is called quasi experiments, natural experiments. For example, if some country has suddenly oil reserves discovered, what will be its impact on basically economy, or for example, if some village gets road the excess immediately as compared to their neighboring village, what will be impact on their welfare. So that is as if random. Though we haven't assigned it randomly to one group to another versus another, but it is considered as if random. So experiment is basically we basically divide our data, our subjects into two groups. One is called control group, other one is called treatment group. I'll discuss this clinical vaccination trial shortly. Quasi experiment, as I mentioned, that it's just like as if random, but it's a natural experiment. And program evaluation assessment, these experiments are used for program assessment. For example, if we are giving income support to millions of people, poor people, then what will be impact of providing that on their welfare now and when it was not provided, or those who are provided versus those who are not provided. Sometimes we have you see campaigns to cut smoking, to save energy, and many other programs. So you can evaluate their impact. Different types of experiments. For example, you have clinical drug trials. These days they are going on at very fast speed. Coronavirus, whether a treatment group, if you get that vaccination, and if you are lucky that you are getting it right now, then whether it will increase your resistance level, it will provide you immunity against corona or not. So there is an experiment, there are experiments going on. I am going to a vaccination trial, I get an injection, whether that was a placebo, that is a neutral injection, or was it a corona vaccination, I don't know. Even the person who is injecting me does not know. This is called double blind. When subject and experiment both don't know, that is called double blind. When only subject don't know, that is called single blind experiment. Job training programs. For example, you are providing a job to a group of people in your company, whether it will increase their productivity or not. So that's basically those who are not getting that training, they are your control. Those who are getting training, they are your treatment group. Whether class size increase leads to low test score. This is a 4-year experiment which we'll discuss in these videos. Star analysis of star data, 3 class sizes, regular class size, regular plus 8, small class size. Our treatment of experiment, ideal, what are the main threats to internal validity and external validity of regression of actual experiments? What are flaws in actual experiments that result correlation between X and U, as was the problem in our regression analysis? Some of the how we can address these threats. Ideal experiments and causal effects. So you see here we have regression equation where X is basically your treatment group. So if X is assigned randomly, for example, if 100 people are given vaccination treatment, other 100 are randomly assigned to control group, it means their other factors are not going to affect that. So it means X and U are independent of each other. It means in ideal experiment, we can measure causal effect of X on Y through beta. So how we measure, that is average among treated group minus average among control group, whether this difference is significant or not. If this is called, we call it differences estimators. Another one is difference in differences estimators, that we'll discuss shortly. Okay, threats to internal validity and external validity. Internal validity, we fail to randomize. For example, job training program is given to people whose name begins, ends with certain ethnicity. So it means we are basically not randomizing properly. So failure to randomize, job training is provided to first come first basis. It means latecomers are your controls, which may lead to why latecomers. So latecomers may have some other reasons. They think that training is not useful or some other reason. So X and U will become correlated. Failure to follow treatment or partial compliance. Many a times, what do we see, that we enter in job training, and in the middle we may leave it, and at the end we may join. Same is the case with classes, in many other cases, even in cases when we get medicine from our physicians, we take it for 2 days, for 3 days, and then we leave. Blood pressure pills, cholesterol medicine, and all that. So it means failure to follow the treatment protocol. Errors in variable, attrition. Many a times, basically, we start an experiment with 100, 200, 400 subjects, but due to some reasons, some people drop out of it. Where they think that they are competent, they are more able, and then they get job and shift out of town, shift to another organization. Or for example, if we are doing this some psychological therapy to children, their parents think that it's not very useful, they pull their children out of that program. So we started with 100 and we are left with 60. So that is an attrition problem. Another is Hawthorne Effect. What is Hawthorne Effect? Basically, when you have in your conscious or subconscious that you are under observation, so you are putting extra effort, you are putting extra care. This was an experiment conducted in New York in 1920s, Hawthorne Effect by General Electric Company. So this correlation between X and U is not zero, because you are getting treatment and you are doing better than that treatment effect, because it is you have something in your subconscious or conscious that it is basically you are under observation. So they have basically conducted this experiment by wearing different amount of light, that whether light level increase your productivity or not. In actual data, there was no Hawthorne effect, but in general, when experiment is when subject is under an impression that he or she is observed, he or she may perform better. That is called Hawthorne effect. Non-representative sample, for example, if we do something and we compare volunteers versus non-volunteers, volunteers may be different than non-volunteers. So if you have only volunteers in your sample, that is a non-representative sample. Non-representative treatment. General equilibrium effects, in general in economics, when we do experiment, those are conducted at a very short scale. But when we discuss general equilibrium effects, it means the factors which were ceteris paribus at small scale may not be ceteris paribus at large scale. The other factors may not be held constant. So therefore, we have to be careful that whether those small scale experiments are also valid at large scale as well. Okay, we'll discuss it, difference in difference estimators and all these things in our next video. Thank you for watching. Take care.